Today in this video I want to conduct an experiment about the RMS value of an alternated signal. We know that I came across watching a YouTube video this image, and this image is it's pretty easy to understand. And it's basically saying that we have two circuits. One is fed with direct current and one with alternate current, and every circuit will produce an effect on the light bulb, which will be to light up. These two circuits will be, this condition will be identical if, as you can see here, if the voltage of the direct current circuit will be equal to the RMS voltage of the alternate current circuit. So I thought I'd conduct an experiment, and I want to show the results. I will conduct two experiments actually. One is with a light bulb, and one is with a small resistor, which I will measure the heat effect on. And the resistor is just inside here. It's 200 ohm resistors in parallel to make it 50 ohm. And this is the K sensor of the multimeter to measure the temperature. I just used a bit of heat shrink tubing to keep it in place over the to keep the thermocouple over the resistors, and to measure the then the temperature attained under the current flowing through the circuit and through the resistors. So the resistor will be in fact the light bulb in the second experiment. So let's start with two light bulbs. So I will use these light bulbs. These are 12 volts light bulbs, and we will examine the two conditions at the same time. Okay, I have reproduced now the two circuits, and those are right here. And we've got two light bulbs, one on the left, one on the right. This one on the left is fed through these two inner cables. The DC current flows through the bulb and is coming from the power supply right there. And I'm checking with the multimeter the voltage across the bulb. On the right side, I'm feeding an AC signal through these two clip-on, and the AC signal is coming from this generator, and I am at 100 hertz. It doesn't matter the voltage that I'm telling the generator to produce. I'm checking the voltage that results here at the bulb with the help of the Marconi multimeter. Okay, so which will be an RMS value. So let's switch on the DC circuit. That's on, and I'm measuring 3 volts. And let's switch on also the AC circuit. That is on. As you can see, the bulb, and I'm measuring almost 3 volts. Let's go a little bit, about 3 volts. So anyway, it's not that critical, okay? 3 volts AC RMS. So let's switch off the light, and we can actually compare the light, which is quite the same. So this experiment is telling us that it's true. It's demonstrating what was being said in this picture and by the theory. Okay, let's now go ahead and replace the light bulbs with the resistor and measure the temperature of the heat dissipated on the resistor, but this time will be in 2 different steps. So we will do the direct current circuit first. Okay, I have set up the experiment. We've got the resistor inside here, which is now connected to the DC supply, which will give us 3 volts. The temperature sensor is connected to this multimeter. We'll check the temperature here, and on these leads we are checking the voltage drop, or let's say the voltage across the resistor. So let's start the DC source. DC source is on. The DC voltage is 3 volts, and the temperature is going up. Now it will take a while to reach a certain temperature and stabilize there, so I will come back when it's done. Okay, the temperature is slowing down. It is reaching kind of an equilibrium. It's not there yet, but yeah, as you can see, it's around 30.5. Yeah, let's give it a bit of time more. Okay, now it's kind of stable, 31.1, 31.2 degrees Celsius. So let's switch the DC source off now, and let's go connect the AC source for the same 3 volts RMS this time. Okay, we are now connected to the AC source. The temperature is slowly going down, the resistor is cooling down. So let's switch on the AC source, and yeah, let's also set the very same voltage, which in this case will be, you know, RMS AC voltage. And once again we wait for temperature to reach its equilibrium. Okay, now the temperature is reaching its equilibrium, 31.1, 31.2, 31.3, which is pretty much the same result we had before. The AC voltage, excuse me, the cables, is 3 RMS. So we are in fact giving 6.1 here, because we are set for high load impedance. This internal impedance is 50 ohm, the load there is 50 ohm, so we are pretty much dividing by 2. So yeah, I would say the experiment is kind of demonstrating the theory, and yeah, it was just a fun idea I had in mind to go ahead and do this experiment to check this theory actually. So, and it worked as it should be, you know. But it's fun. It's fun to do these experiments and see actually how the theory behind is working in reality. Obviously, there are some uncertainties about you know, the measures we are taking, about the multimeter, about the voltage. This is especially this one. It's not very accurate for voltage reading. I could set it up a better way, but I just to have a rough idea, you know, that the concept is working actually. No? That's all. Thank you for watching. I hope you found this interesting. All the best. Best wishes until the next video. Bye bye.